Hello class, these are our notes for section 517, different compounding intervals. In many situations, interest is calculated more frequently than once a year. How often the interest is compounded and calculated and added to the previous amount affects the overall amount of interest earned or owed over time. Suppose a bank account has a balance of $1,000 and a nominal annual interest rate of 6%. No additional deposits or withdrawals are made. Fill out the table for different compounding intervals, as well as the corresponding expressions for the account balance in 1 year. So we have $1,000 is what we're starting out with, and our interest rate is 6%. So let's remember that 6% as a decimal is 0.06. But really what we've got here is we've got 100% of our money plus that 6% interest, which is 106%, which is 1.06. So let's remember that our balance at the end of the year is not just 6%, but also 100% or all of the money we started out with. So all of the money we started out with is the 100%. The 6% is what we're adding on. So that's if we only did one time a year. So that's actually going to be this first row. So if we looking at adding our interest or compounding it just annually every 12 months, that means in a year that's going to be one time. And so our nominal interest rate is 6%. And what we have to do is we would have to take our $1,000 and we would multiply by 1.06. And that ends up being $1,060. Sometimes they're going to rate it as 1 plus 0.06. We'll get into more later on in this unit why we might want to do it that way, but they are the same thing. Semi-annually means we would be looking at 2 times per year. So if we want this to be 2 times per year, then what I would have to do is I would have to take my interest rate, 6, and I would have to divide by 2. So that would give me 3%. So what happens is I'm going to look at this happening twice, and it's going to be a 3% instead. So now I'm going to have 1,000 times 1.03. And then because I'm looking at semi-annually every 6 months, this is happening 2 times a year, I'm going to raise it to the second power. So when we multiply this out, we end up with a little bit more money than if it's just once a year. 1060 and then an additional 90 cents. It's not a lot, but it's something. And that's because, again, we're stopping halfway through and then we're multiplying by that 1.03 again. So it's like we're earning interest on some of the money we've already earned interest on. Quarterly, every 3 months would be 4 times a year, right? 3 times 4 would be 12 months. And so this is going to happen 4 times per year. That's why we say quarterly. And so our interest rate is going to be the 6% divided by the 4 times per year. If I reduce that, I could get 3/2. Really, a decimal's better here. That's going to be 1.5%. So that means I need to take 1,000 and multiply by 100% plus the 1.5%, so 1.015. And I'm looking at 4 times a year, so I'm going to raise it to the 4th power. So I have taken that interest rate and I've split it up into fourths, but I'm also raising it to the 4th power to get my year back. This one ends up being 1,061 and 36 cents. I'm seeing a lot of people struggle with calculator use. This isn't something that you can do on one of our baby calculators. You really have to have a scientific calculator for this. So it's going to be best if you purchase that yourself. We have some available in class. You should be able to put something like this directly into a scientific calculator and get an answer. Please let us know if you need help with this. The last one, monthly, means I would be doing it every single month for the whole year, which would be 12 times. And the way I would get that interest rate is I would take my 6% and I would divide by 12, and that's going to be 1/2 or 0.5%. So 0.5%, and I feel like that's kind of in the way. I'm going to put this a little bit lower in the box so I have room for the next box. So that's 0.05, or sorry, 0.5%. I put too many zeros in there. 1/2 is 0.5. So if 1/2 is 0.5, we're looking at 0.5%. And then when I write that as a decimal, it's going to be 1,000 times 1.005, and then to the 12th power. And this one's going to end up being 1061 and 68 cents. So it doesn't make a huge difference, but it does make a difference. You're earning about $1.50, not quite $2 more by compounding more frequently, right? That's what compounding does for you. So you can think about how if instead of having $1,000, you started out with $10,000, you're going to get to see more of a difference there, right? The more money you have, the more you're going to see the effects of those compounding. So notice that the more frequently the interest is calculated, the greater the balance is. This is the main ideas for our notes today. As always, if you need help, please make sure you ask.